Hi, I'm Dick Gross. Welcome back to Fat Chance. This is our first official lecture. As we've discussed in this course, we're going to teach you some techniques to calculate probabilities, to estimate statistics of events. But to do those kind of calculations of probability, we have to learn some basic techniques in counting. Because probabilities are always the count of some events divided by the count of another set of events. And the wonderful thing about the number system that we have, the numbers 1, 2, 3, 4, 5, is they can be used to count almost anything, even numbers themselves. And that's how we're going to start the course, by counting numbers. For example, here's the first problem. Sounds pretty simple. How many numbers are there between 1 and 10? And when I ask for the numbers between 1 and 10, I mean including 1 and including 10, the two endpoints. Well, that's a problem we can solve with our fingers. We just count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 numbers between 1 and 10. Great. But then suppose I asked you, how many numbers are there between 1 and 283, including, as usual, 1 and 283? Well, we don't have enough fingers to do that. But we can figure out the answer by working up to that more difficult problem through a sequence of simpler problems. Between, for example, 1 and 11, well, they're the 10 numbers that we've counted out between 1 and 10, and one more, 11. So there are 11 numbers between 1 and 11. How about between 1 and 12? Well, they're the 11 numbers we've calculated out to 1 and 11, and 12. So that gives us a total of 12 numbers. And if we continue this way, adding one number at a time, we find that there are 283 numbers between 1 and 283. And if I said how many are there between 1 and 369, there'd be 369 numbers. Well, that doesn't sound so interesting. Let's add a feature to make it a little bit more interesting. Instead of the numbers between 1 and 283, suppose I asked you, how many numbers are there between 23 and 283? Well, how would we do that? Well, we know how to count all the numbers between 1 and 283. There are 283 of them. And we want to just throw away the numbers between 1 and 22. Then we'll have the numbers remaining between 23 and 283. How many numbers are we throwing away? Well, those are the numbers between 1 and 22. That's a problem we know how to solve. There are 22 such numbers. So the total number of numbers between 23 and 283 is the numbers up to 283, minus the 22 numbers between 1 and 22 that we don't want to include. And 283 minus 22 is 261. And that's the answer to the problem. There are 261 numbers between 23 and 283. Good. Well, here's another way to do this. We're trying to calculate the numbers between 23 and 283. Let's make a list of all those numbers. It starts with 23, then comes the number 24, then comes the number 25. Well, we can't make this whole list on the screen. So we'll use a mathematical convention. We use a sequence of dots, dot, 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 to indicate the same sequence of numbers, namely 26, 27, 28, all the way up to 280. And then we list the last three numbers that we're trying to count, 281, 282, 283. So the sequence of dots is just mathematical notation that allows us to write down these numbers without writing them all out. Okay, so in any case, we have a list of these numbers between 23 and 283, and we want to count them. Well, we don't know how to do that problem, but suppose I told you to subtract 22 from each term on this list. The first number, minus 22, is the number 1. The second number, minus 22, 24 minus 22, is the number 2. The next number gives 3. We get another sequence of dots from all the numbers, from 26 minus 22, 27 minus 22, etc. When we get up to 281 minus 22, that's 259. 282 minus 22 is 260. 283 minus 22 is 261. So we get a new list of numbers, which has exactly the same number of numbers as on our first list, because to each number on our first list, we've written down that number minus 22. But now we have the numbers between 1 and 261, which we know how to do. There are 261 numbers between 1 and 261, so that's got to be the answer to our original problem. And I note that it agrees with the answer we got using the previous method, counting all the numbers and then removing the numbers from 1 to 22. We got 261. And that's important because in mathematics, there's only one correct answer to a problem. It's not a matter of, on the one hand, this, and on the other hand, that. If you do a problem using two different methods and they come out the same answer, that's a check on what you're doing. And if you get different answers, then at least one of the methods is wrong, because you can't have two different answers to the same problem. Okay, now, once we understand a pattern in this course, we're going to want to write down a formula to express it. So for example, here's a really simple formula. The number of numbers between 1 and any number n is just n itself. If n is 361, the number of numbers between 1 and 361 is 361. A slightly more complicated formula is to count the numbers between a starting point k and a larger number n. And we want to count the number k and n. So that's like the problem of the numbers between 23 and 283. All right, so how do we do that? We count all the numbers up to n, there are n of them, and we remove the k minus 1 numbers between 1 and k minus 1 that we don't want. And then we'll just be left with the numbers between k and n. And so the total number of numbers is n minus k minus 1, which you can rearrange after removing the parentheses as n minus k plus 1. That's the total number of numbers between k and n, including the two n numbers. Now, don't get seduced by this formula. When we have a general formula, like this one, n minus k plus 1, the key thing is to remember how we derived it. We have all kinds of students who come into the exams here, all over their skin is written these formulas in pen that they're trying to remember for the exam. But that doesn't do any good, because once you wash your hands, the formula is gone. It's much better to try to remember what we did to get to that formula, and then you can recover it if you ever forget it. Okay, now having counted the numbers between k and n, we might stop, but let's take it up one more notch in this lecture. All right, suppose I asked you how many of the numbers between 23 and 283, and we found that there were 261 of those numbers, how many of those numbers are divisible by 5? Not all of them are. 23 isn't divisible by 5. 283 isn't divisible by 5. So we're counting a smaller set of numbers. Among all those numbers, how many are divisible by 5? Well, again, we can list them out. The first one divisible by 5 is 25. Now the next one on that list is 30, and then 35. And since we can't write them all out, we use our conventions of ... And the last three are 270, 275, and 280. So there's a list of numbers. Those are the numbers between 23 and 283, which are divisible by 5. And we want to count the numbers on that list. But that doesn't look like a problem we've done. How can we turn that into something we've done before? Suppose we take every number on that list and divide it by 5. Remember, every number there is divisible by 5. So 25 divided by 5 is the number 5. 30 divided by 5 is 6, the next number. 35 divided by 5 is 7. We divide the dots, and then the last three numbers give us 54, 55, and 56, which is 280 divided by 5. Well, this is a list of numbers we know how to count, because it's just the numbers between 5 and 56. So the total number is 56 minus 4, or 52 numbers. N, in this case, in our formula, would be 56. K would be the number 5. N minus k plus 1 is the answer, 52. And that's the answer to our original problem, because there are just as many numbers on this list as there were on the original list divisible by 5.